And another question related to hydrocarbons is at 300 Kelvin and 1 atmospheric pressure, a 10 ml of hydrocarbon requires 55 ml of oxygen for its combustion, and in this process it generates 40 ml of carbon dioxide. Then you are asked to calculate the formula of the hydrocarbon. Whereas this is hydrocarbon is allowed to react with the oxygen. As a result, it is producing carbon dioxide followed by some others. Whereas the information related to the given hydrocarbon is, this is at the same constant temperature and the pressure conditions. This is 10 ml. Whereas this 10 ml is allowed to react with 55 ml of oxygen for its complete combustion. And in that, here the amount of carbon dioxide produced is 40 ml. Amount of carbon dioxide produced is how much? 40 ml. Whereas 10 ml of hydrocarbon on reaction with 55 ml of oxygen, it is producing 40 ml of carbon dioxide. In the formation of carbon dioxide, whatever carbon is present, 1:1 ratio of carbon and the oxygen combination results carbon dioxide. So therefore here 10 ml is combining with some amount of oxygen, resulted as 40 ml of carbon dioxide, implies in that 40 ml 1 is converted to 4 molecules, implies the amount of carbon is, that is 4 times of carbon is present. So therefore C units are found to be 4. Whereas to form 4 molecules of oxygen is required, that is 4 times of hydrocarbon quantity, that is 40 implies remaining is 15. Whereas remaining is 15, this 15, the amount of oxygen is found to be 15 implies 1.5 times, 1.5 times implies, so therefore hydrocarbon versus amount of oxygen consumed is 1:1.5 times. Whereas the hydrogen, for every 2 hydrogens, half molecule of oxygen is required. So therefore they should be present in the ratio of, if it is twice, this should be half. So therefore here whatever the hydrogen quantity is there, here the hydrogen and the oxygen related relation to form the water, if you look at, one hydrogen requires 1/4 molecules of oxygen to form the water. Here the ratio is present is 1.5 times. So therefore the amount of hydrogen related amount of hydrogen with respect to the amount of oxygen is 4 times. So therefore for one molecule this is 4, implies 6 hydrogens are present. Thus the formula of the given hydrocarbon is found to be C4H6.